simplifying rationals. Now, simplifying rationals can come before or after adding or subtracting rationals. I like to do it after because it flows better with all my other lessons. But it doesn't really matter the order that you see this in. But here we go. Let's try this out. So simplifying radicals, we're going to start off with rationals. We're going to start off with simplifying a fraction. Now, many of us learn that we can take both of these numbers and just divide by 8. And we get 1 over 2. And so even though that is correct, it doesn't actually help us simplify it when we have rationals like the problems below. So what can we do? Well, we can actually just factor first. So we're going to factor 8. So 8, I'm going to do it on this side. So 8 is just 2 times 4, which is 2 times 2 times 2. So I'm going to write 2 times 2 times 2. 16 is just 2 times 8. And we already know that 8 is 2 times 2 times 2. So we have that 2 and then 2 times 2 times 2. And so now what do? We make ones, right? We start to divide each pair. So 2 divided by 2 is 1. 2 divided by 2 is 1. And 2 divided by 2 is 1. So what are we left with? Well, in our denominator, I'm left with a 2. I can clearly see that. But what's up here in our numerator? Well, since everything became ones up there in the numerator, we just do 1 times 1 times 1, which is 1. Okay? And so I know you're probably thinking, like, that's a lot of work. Well, it's actually the correct work and the work that is consistent to help us simplify our fractions, our rationals. So what's next? Next up, we're going to factor. Because a lot of this that we have to do first is factor. And you're going to see that you're going to have a bunch of polynomials, whether they're quadratics or cubics or even quartics, right? It doesn't really matter, but we have to factor. And I'm actually going to add an extra problem on here. And that problem I'm going to add is 3x squared plus 7x plus 4. Okay. Because I want to make sure that you know how to factor each one. Now, I'm not going to go over step by step. If you need a step-by-step guide, you need to look up a different video. I don't have any out as of 2025. This is April 2025. But come the end of fall, I should have some. So depending on when you watch these, decide if I have factoring videos. All right, so the first thing I'm going to look for is always a GCF. And so when I look at the first example, I see that I have a GCF of 8x squared. And if I divide 16 divided by 8, I get 2. X cubed over x is x. 8 divided by 8 is 1. X squared over x squared is just 1. So we're nothing there. There we go. We factored. Number 2. So I'm going to put GCF so that you remember that that's a GCF problem. Number 2. How do I factor that one? Well, it doesn't have a GCF. There's nothing in common between 49 and 16. But I see that this is a difference of 2 squares. What does that mean then? If I see a difference, that means I have a plus and a minus as my factors. And I kind of just mentally just take the square root of both those numbers. Square root of 49 is 7x. And the square root of 16 is just 4. And if you were to multiply this by together, you'll see that they are the same thing. Okay? And then last but not least, how do we factor this one? Depending on what class I teach you in, or what level you are on, it depends on how you factor this. So I'm going to go ahead and just factor it. 3x times x is 3x squared, which gives me 4, where the multiples of 4 is 1 and 4, 2 and 2. I'm going to try 4 and 1. I know I'm going to have the same signs. They're going to both be positive. And then let me check. That's 3x. That's 4x. That makes a 7x. So these are the right ones. I'm going to go ahead and get rid of this. So those are the factors. So these are the different ways we're going to factor these problems in order to simplify them. Okay. I'm going to put a 2 right there. I made a mistake when I made these notes. There we go. So how do we do this? It's simple. We're going to first factor. So that's probably not the simple step. You got to work on your factoring skills. And then we're going to simplify them by making ones, just like we did in the review. So let's do the first problem. So the first thing we're going to do is factor. Now for the first one, you have options. I'm going to leave mine as 8x squared One of my classes I was teaching this in actually factored out the 8x squared. They put 2 times 2 times 2 times x times x. It's really up to you. There's no right or wrong answer on how to factor this one. It does depend on that problem itself. Sometimes making it 8x squared and leaving it is easier, and sometimes factoring it out is easier. So it really just depends on you. You have to decide what's going to be beneficial for you. This is the exact same example we had up top. This is a GCF problem. So it's 8x squared x 2x plus 1. And now we're going to make ones. And how we make ones is they have to be the same on the numerator and the denominator. So notice I see 8x squared, 8x squared. I made those ones. So now what am I left with? 1 on top over 2x plus 1. And we're done. We can't simplify this anymore. Question number 2. We factor. So take a moment, see if you can factor this. I would pause my video, see if I can factor this one on my own. Okay? So hopefully you pause your video. You find out that your GCF for the numerator is 4x squared. And 3x squared minus 1 is the factor. The GCF is 2x squared with 3x squared minus 1. So what do I see that's the same? Well, I see that these both have 3x squared minus 1. Now, there is going to be a rule that I show you later on. But notice how they both have parentheses. This is a pairing. A pairing happens when that binomial has either a plus or a minus in between them. Okay? When they have a plus or a minus in between them, we can't cancel things out until unless they're the same. So, for example, I'm going to erase this really fast. For example, I can't cross out x squared because it's a binomial and it has a pairing. Those things cannot be crossed out unless the binomial itself is being canceled out. Remember, a binomial is 2 terms. So the fact that this is 2 terms in the numerator, there's 2 terms in the numerator, I can't just cancel out part of those terms. I have to either cancel out the entire thing, but I cannot cancel out some of the things. So back to this example. I have a binomial now. Since I canceled this out, since I factored it, I can cancel out the entire binomial. And then what do I have left? I have 4x squared over 2x squared. Is there anything else I can cancel out? Right? Now, these are not binomials. This is one term. This is a monomial. I can cancel out monomials. So those 2 cancel out. So what am I left with? 4 divided by 2. Well, hopefully you know 4 divided by 2 is 2. This problem looked very complicated. It had all these different things happening, these 2 binomials to the 4th power, and it all simplified to be 2. If I was to put this equation into Desmos, you will find out it's a straight line or horizontal line through y equals 2. That's this point. These 2 things were equivalent. So that's what makes this, that's not what I want to erase. That's kind of what makes these things cool, is that you get to simplify them to actually see what they really are in their true nature. Next one. So again, find your GCF. I will pause my video and see if I can find my GCF. And I can factor this completely. So the GCF for the numerator is 4x. And when I factor that out, I get 5x plus 3. The GCF for my denominator is 4x squared. And when I factor that out, I get 5x plus 4. So what can I simplify? So I want you to pay attention to this binomial. This binomial is 5x plus 3, while that binomial is 5x plus 4. These are not the same. I cannot cancel those out. So that means these binomials are stuck the way they are. So what about over here with the monomials? Can I simplify these monomials? Well, right now I have a 4 over 4. Those can cancel out. What about this term here? The x over x squared. So what I'm going to do is I'm going to rewrite this as x over x times x. I'm leaving everything else the same. Now, remember I said over here in this example that you could factor out some more, or you don't have to. It depends on you and your level. So sometimes my students don't see that we can simplify some things. until they write it out. So I advise you to expand it if you have to. This x squared is just x times x. And so what do I see? That these are binomials that are multiplied together. I can cancel them out. And so what does that leave me with? 5x plus 3 in the numerator. Oops, let me change that back to a 4. And in the denominator, I have x, because that x was left over, 5x plus 4. Now notice I didn't put parentheses around here because there's only by itself, so it doesn't matter. I don't need parentheses, so I don't have to have them. Down here, I do need parentheses so that I can remember that the x is being multiplied to it. All right, anything else? Remember, I cannot cancel out these 5s because they are binomials and they're together. I can't cancel out those x's because that's in a binomial. It's together. So if it's a binomial or a trinomial, we can't just cancel it out unless it's a matching pair that's being canceled out. Okay, last 3. I am going to move a little bit faster because the only process that's going to be different is how we factor these. But canceling things out is the same, making ones. Okay, they're the same thing. So I'm going to go ahead and factor. This looks like the GCF, not the GCF, the difference of 2 squares. So the square root of 25 is 5. Square root of 1 is 1. There are differences. Boom. All over x plus 3. Well, I don't think anything can cancel out. Right? These are all binomials. So if I was to cancel out these binomials, they have to be in pairs. So I can't cancel those out. This is simplified. So if I was doing my Get More Math, your answer that you would put is actually simplified. If it's a button, you could just press it. Number 2, we're factoring. So you might want to pause and see if you can factor this correctly. Hopefully you paused your video. And if you did pause your video, you should have had 3x. That's an x. We know it's going to either be 4 and 1 or 2 and 2. The signs are going to be different. That's 3x, or negative 3x plus 4. That's going to give me a 1. I checked my work. Watch. 3x times negative 1 is negative 3x. 4x, that's a positive 4x. I combine those together and I get a positive x. And that's what I needed. Sweet. My denominator does not simplify. It's just going to be x minus 1. All right. Does anything cancel out? Well, all I have is a binomial, binomial, binomial. These are all binomials. So if I cancel out any of those binomials, they have to be matched with the pair. And I do. I have a binomial here and here that cancels out. That leaves me with 3x plus 4. Big difference I want to talk about, the difference between 1 over and the binomial. So notice over here in example 1, when I cancel it out or I made ones here, the numerator had just a 1. There was no other number involved. I have to put that 1 now. In the other example, my denominator was canceled out and I had no other denominator. I do not need to put that 1 there. Okay? So for the small example, right? If I have 1/2, I have to keep the 1 because that's 1/2. But if it's 2 over 1, I do not need it. I can keep the 2. So you kind of have to know the difference between those two things. Okay. Last example. Again, I hope that you take the time out to factor this problem on your own to make sure you can factor it. You pause the video. No one's with you to know how long the video was paused, but you should try these out yourselves. Okay, so I paused my video, hopefully, and I go ahead and factor. The denominator is the difference of 2 squares, so that's an easy one for me to spot. I have another 3x. I'm just 3xing it up in here. Same signs, because that's a 1. I mean, that's positive. That's the same sign, and that sign is going to be a negative. So there it is. Ooh, that's big. Okay. So all these are binomials. Is there a pairing of binomials that cancel out? It is. It's these two. And so what am I left with? 3x minus 1 over x plus 1. That's it. That's all. Those are your two steps. Factor it out. Right? Factor it out first. That's this step in red. And then simplify it by making ones. Remember, if it's a binomial, you have to cancel out with another matching binomial. And it has to match perfectly. A question that some of my students were asking me is x plus 1 over x minus 1. Can I cancel that out? The answer is no, because they're not the same. They have to be the exact same binomials. Okay? If you have any questions, you can always hit me up. Thank you for stopping by.